Hey RAKstars, welcome to the last Hangout with RAKstars session of this 2022. Today's session will be just a in-deep look at some of the
Hey
products released
RAKstars,
at
welcome
our
to the last
recently
Hangout with
launch.
RAKstars session of this
Oh, I think I have an echo
2022.
somewhere.
Today's session will be just a deep
Oh,
look at some of the products released at our recently launch.
can you check some of you
Oh,
guys
I think
if
I have an
someone? Okay,
echo
it's on my
somewhere.
side.
Session will be just a
Oh no. Okay, some things happen. Hey, Shweta, can you mute your mic just to make sure if there is something right there? Hello, hello, hello. Okay, I think there is an echo right there, but all good. So, just jumping once again, this session is going to be an in-deep look at some of the products that we released in our recently launched event a few months ago, and we're going to be sharing this session with some of our RAC team members, as you can see over here. In case you haven't seen this launch event, we invite you to check it out in our YouTube channel just to keep up to date with the latest things that RAKwireless introduced to its hardware and software ecosystem. And before I start with the session, I really want to take a short space to thank you all for have been recurrently joining these sessions since we revived them once again. We are doing this space just to connect and learn all together. So make sure to follow the RAG Wireless channel to be notified every time that a session is announced. So yeah, as we have a lot to share over this session, let's just jump into the intros of these top guys that we have over here. Here we have Johan Macias, our developer advocate, as well as our other hosts over this Hanons with Raxter session. Xose Perez, with Gate Connect product owner, Rowan, technical marketing, and Christopher Mendez, a solution architect. Welcome, guys, and thanks for being here.
Hey Maria, hey guys. We were missing you all at this stage. I remember a few things about the previous sessions where every one of you participate in. I remember Jose shared some projects with the rack concentrators to create gateways. Christopher talked about his tiny ML projects with the WizBlock, and Carl provided an overview of RUI3 for our WizDuo modules. Time flies, and I'm sure you will have several ideas to share with us today.
Completely. It was just like it feels like what's yesterday, but okay, there are many things that happen over this year. We have like a pretty cool projects and products going on, and today will be that space to share all of those things. So yeah. In addition to all of these, if someone of you, those who are connected right there, have any question, feel free to leave your doubts and questions over the comment section. We are going to be jumping off this question if meets our conversation, or if not, we're going to leave it by the end of the session. So yeah, let's just go into the session. And as Johan shared, you have been already part of this. And if someone wants to find out more about all the things that these guys have been doing in the past, with either working with rack related products and not, you can check out the Hands with RAKstar playlist in our YouTube channel and check an 1 hour session with each of these awesome guys on our YouTube channel. So just for those who are here today, can you just share a brief about you, your career background, about and also about the things you have done over RAK over this year? So you can go as you prefer. Feel free to unmute your mic. Thanks, guys.
Okay, so I shall start if you don't mind. So yeah, I'm Xose Perez. I'm product owner at RAKwireless. I've been working at RAKwireless for 2 years now. Before that, I was CTO at a LoRaWAN, not LoRaWAN, sorry, LP1, not LoRaWAN, LP1 company startup in Barcelona. We were using a different technology, not LoRaWAN, but something called WISE, which is what water management companies use here. And before that, well, playing around with hardware and software. Actually, I come from the software world, so it's only been like 10, 11 years that I've been playing with hardware. And it's way more fun, to be sure. Yeah. So, and these 2 years working at RAK, I've been doing some stuff, but one of them is what I will be showing just in a few minutes, the WizGate Connect. So I will talk about it later.
Awesome, awesome. Thanks, Joseph, for bringing that.
Hi everyone, I'm Carl Rowan. I'm technical marketing at RAKwireless. Started at RAK 2020, so like you say, I am 2 years in on RAK. I'm an electronics engineer, so basically my background is hardware, but my work and my interest was a combination of both. So it's software and hardware because I like the ability. If you know firmware, you can tweak hardware functionality with codes, not changing resistors and capacitors. So that got my interest. I started with LoRaWAN like 2018 in a startup company in the Philippines, and now I'm a track. I do stuff related to WizBlock, WizDuo, mainly on end devices. So documentation, technical support, and yeah, the technical marketing side. So it's a fun um, years I have in rock, learning so many things, meeting lots of people, and yeah, that's for me.
Awesome, Karen. Thanks for sharing that.
I think that's my turn now. My name is Christopher Mendez. I'm from Dominican Republic. Just as Carl, I'm an electronic engineer, and I I am running the role of solution architect now at RAK. But first, I was a content creator, just as I've been doing in YouTube for a while. I have 1 year working at RAK here, and one of my recent works or jobs here at RAK was to implement Edge Impulse platform with WizBlock ecosystem so we can develop tiny machine learning applications with our actual hardware. And yeah, today we'll be talking about audio and machine learning with WizBlock a bit.
Awesome, awesome, guys. Thanks for sharing that. As you share, all of you, like you are some kind of specialized on one of our products. RAKwireless provide like an entire infrastructure to develop IoT solution from the sensor to the infrastructure and also to monitor all of the things. So yeah, let's jump into what we have to share today. So, Johan, if you would like to proceed on this, go ahead and take the mic in your side.
Yeah, for sure. It's time to discuss about all the things that we have in our latest launch. So to keep the same flow of the segments from that launch, we are going to start with Xose, because during the initial part we observed the WizGate Connect, an innovative infrastructure technology that allows companies to implement various communication technologies in one place. Jose, please share in further detail about this new gateway that has been added to the industrial wireless family products, and also what alternative software tools can be used to provide remote management systems over a fleet of gateways.
Sure, yeah. So as I was saying, the WizGate Connect is one of the new products of RAK Wireless. The idea of the WizGate Connect, but actually it started like those ideas that you think, okay, I need one of these, and there's none on the market, so I have to create one of these. And the idea is that if you know, we already have like developer gateways based on the Raspberry Pi, and we have edge gateways based on MediaTek and a system on chip. And the thing is that they are both great. Of course, you are going to deploy developer. Sorry, you're not going to deploy developer gateways, and you could, but you would prefer to deploy the edge gateways, which are ready to be deployed. The other ones have a lot of potential in flexibility, but they are based on a Raspberry Pi, which sometimes it's a problem, let's say, because of the SD card, because of other things related to the range of temperatures that they support, this kind of stuff. So the idea of the WizGate Connect, the first one of the ideas is to bridge these two different families of gateways. So have something in the middle that is as flexible as the Raspberry Pi ecosystem, and something that you can deploy um, with confidence on the field. And that's what we created. The WizGate Connect is it's actually a carrier board based on the Compute Module 4, so Raspberry Pi Compute Module 4. You can use it the very same way you use a Raspberry Pi, but it does have industrial degree components, and it supports like a range of minus 20 to 85 degrees temperature. It doesn't have an SD, or it doesn't have to have an SD card. You can use an eMMC, or you can even use a solid-state drive to hold the operating system. Thank you, Maria. Yeah, this is one of the things that we wanted to create. And if you know about RAK, you know that we are fans of creating modular approaches, just like the WizBlock, something you can just build. And we try to do the very same with the WizGate Connect. It's a platform that you can tailor to your needs. So you will have a CM4, a Compute Module 4. It supports all the different variants of the Compute Module 4. So you can have a light variant, or you can have a 32 gigabytes of eMMC and 8 gigabytes of memory. So that's pretty impressive for a core. And then you can have a module for PoE support. You have, of course, you can connect a Raspberry Pi hat, and you can connect up to 3 mini PCIe boards, like the ones we are using for LoRaWAN, or like the ones we are going to release soon of other radio technologies, or even third-party mini PCIe boards like Wi-Fi 6 or Zigbee. You can use it with the WizGate Connect. And you also have 2 WizBlock slots, WizBlock I/O slots. So if you know about WizBlock, we have a wide range of options. Some of these are in a sensor form factor, and some of these are in a I/O form factor, we call it, which are meant for interaction, like Modbus, CAN bus, LIN bus, or 420 milliamps, or analog input, or relays. A lot of different industrial related options that you can use directly on the WizGate Connect. I'd like to show you, before keeping on talking, because I kind of have this tendency to talk a lot. Before keeping on, I'd like to show you what it looks like. Of course, you can check the website, and you have there all the options, but maybe in real life, it's like, so I have one of these. So one of the things that, when talking about modularity, is that, of course, you can use the PCB and add these different cores, or add different mini PCIes, or add a WizBlock, or whatever you want. But you can also choose the enclosure. And we have 3 different enclosures for the WizGate Connect. This is one of the enclosures we have. This is a 1U size, so you can add it to a rack in your server's room. And here I have it. This is meant to be just, this is a LoRaWAN gateway right now. But as you can see, I have here a WizBlock module, which is a Modbus module. So this gateway is ready to be connected to an industry, and have Modbus connectivity on it. The other one that we have for indoors, I don't have any sample here, but maybe Maria can show the aluminum enclosure, which is, I think, really nice looking. Yeah, it's the one in the middle on the picture, maybe. Yeah. I'm not sure if you can click on that picture. The idea is the very same as this one. You will have all the different ports exposed, like different options for antennas, up to 6 different antennas. Mind that you can have multiple radios inside this thing. You have 2 1 gigabit Ethernet port and 1 2.5 gigabit Ethernet port. The 1 gigabit Ethernet port is PoE compatible. You have 2 USB 3 ports, 1 USB 2 port. You have HDMI out, and you can also power it via PoE, as I said, or a jack, a typical 2.1, 5.5 jack, or a Phoenix connector. And on the other side, you have the different slots for the SIM cards and a nice, small but nice, because it lets you give you some information about the processes running inside an OLED screen, a small OLED screen. So this is it. The aluminum enclosure is the same, although I think it's much more nicer, the other one. And then we have the outdoors enclosure, which is the very same that we use for the Edge Pro gateways. This one. So it does has PoE, and I have it open, and actually it's running, so you can see what it looks like in the inside. Please forget about this thing that I have here. I didn't have a long enough cable here, but you can see that we have the CM4 here. We have a PoE module. We have two mini PCI cards here, and that's pretty much what it has. This version. One cool thing here is that you can have multiple LoRaWAN gateway, LoRaWAN concentrators, and actually one of these is a 868 LoRaWAN concentrator for Europe, and the other one is a 2.4 gigahertz concentrator, which we will be releasing soon, and we are testing right now. So you have two antennas, one for 868 and one for 2.4. And therefore, you can have a gateway in the shape you want. I mean, if you want to add 16-channel gateway, you can do it with this, because we still have one slot free. You can add other technologies. You can add. We have tested with Wi-Fi 6. We have tested it with Wi-Fi Halo, Zigbee, Matter soon. Of course, Bluetooth, Wi-Fi. Yeah. So one of the keys here is that this has the potential to become a multi-radio access network hotspot, something that you can use in a single device. You can have multiple different connectivity options. Yeah.
Definitely, we are talking about gateway specialty in all the scope of the sense. What would be the ideal use cases for the WizGate Connect? Could you share some use cases where this product is being tested right now?
So we are the original idea was to have something flexible and see what happens, because we knew that there was a potential for that there was interest in having this kind of platform, but we wanted to see where it will fit better. And right now we are starting to have some good feedback from customers, and they are basically, of course, there's the gateway thing. If you want a LoRaWAN gateway that you can deploy based on a Raspberry, then you can do it. Since it's a Raspberry, you can actually easily deploy everything you want inside. We have been working on a custom operating system based on the Raspberry Pi OS, but that it comes with Docker by default and with a set of utilities that let you easily deploy Docker containers on the machine. So in no time, you can have the packet forwarder for your LoRaWAN gateway, plus Chirp Stack or the Think Stack or Node-RED or Grafana or Influx, everything in the same device, and it works great. It was just great. So this is one of the use cases, gateway on steroids or just a simple gateway. You can do it. The other one that we see that there is a lot of interest is in the building management systems. So you might know that there are different protocols that are being used in building management or in industry, that they have been there for a long time already, but they are still in use. Protocols like Modbus, like KNX, like BACnet, and we are working on a solution to include all those protocols in a service that we can deploy on the Connect easily. So it will become like a hub of connectivity for smart building solutions. And this is something that we are working hard right now.
Actually, there is a thing that you say at the beginning, and it is that I was looking to create something that I need, right?
Yeah.
Because it is a mix of different things. And it is funny because when we had the opportunity this year of attend to the LoRaWAN World Expo, and there was the place where we first introduced this product to the ecosystem, there were many people and companies that reach out to us just because saying, like, just because they were doing like the initial steps of developing something, and
Mhm.
we already have already there for them, because it is a mix of all the things that they are going to need to be able to deploy it in different applications. So as Soshi said, it's like a modular fully device that can apply like almost any need that you can have for the different industries. So it's
Yeah, yeah, yeah.
pretty
Actually,
important.
my previous job before I was at RAK, I was working on integrating different radio solutions on a gateway. And as you can imagine, it was a mess of cables inside the box. So
Yeah,
it was absolutely. We had LoRaWAN, we had an SDR, we had 4G, we had, and it was like a Frankenstein inside
of
the box.
course,
It worked, but of course it was not a product that we could sell. It was just a prototype. So this was the opportunity to build something that can handle these kind of use cases.
completely. And regarding like the software tool, you mentioned some of them that can be run into this product, but what about the built-in software tools that RAK Wireless is developing for the gateway ecosystem? It is up to run with Gate OS and with DM in top of it.
No, actually not. It's we have not yet integrate both families in that
Okay.
sense. So WizGate OS is not compatible.
Mm-hmm.
Well, actually, it could be at some point, but WizGate OS right now it's focused on LoRaWAN, and this product is much. It's like
Multi.
multi radio options. So if you of course WizGate OS is based on OpenWRT, so you could theoretically you can install it here and it will work, but you will only have like LoRaWAN management. Um, there are other options in the market. We
Mm-hmm.
are installing a Debian and we are providing a set of tools to make it easier to configure. We are going to work on web UI as well soon,
Great.
and of course, you can also use other existing open operating systems for the Raspberry Pi or solutions for fleet management like Balena, for instance. It will work just great.
Awesome, awesome. Thanks for bringing that, because there's a question that I have here from community members if this is up to run this, and I think it's something important to clarify over
Okay.
here. And just as a last question to jump with Car, um, like this is like a multi-radio gateway. It connects different kind of connectivities to apply it to different things. But what do you think it's going to make like a significant impact on IoT in terms of connectivities in the near future?
Well, this is why I think this is going to be great, or solutions like this one are going to be great. I think the future is not about one single connectivity option, protocol, whatever. It's about multi whatever. So you have to get ready to be able to connect, to have different backhaul solutions, to have different protocol support, different radio support. Like this one, for instance, it's the very first gateway that I know of that has both sub gigahertz and 2.4 gigahertz LoRaWAN. 2.4 is something that it's going to be great this year and next year. So the LoRaWAN Alliance and Semtech is pushing hard on this. Um, and but not only LoRaWAN. I mean, there are other protocols out there, and not only wireless. Even there are other wired protocols out there that are going to be important to so that is important to be supported. And that's why the connect. Actually, that's why it's called WizGate Connect because it connects different radio protocols and wired protocols as well.
Awesome. Thanks for sharing that, Sasha, and thanks for bringing and introduce us a bit of Wizgate Connect. For those who want to go and explore more, I just leave a link to the product page where you can check out all the details, see all its features, technical features, either moving forward to the like jump forward to the documentation and see how you can get started with it. So thanks, many thanks, Joseph, for that. So I think it's time for Car to introduce the sensor hub over here. So yeah.
Yeah, the Sensor Hub is a product that many community members have been waiting for because it's finally a plug and play device that allows us to be used in multiple applications and it's ready to deploy. And so, Carl, can you share how this sensor was developed so far and at the same time, what's the connection it has with the Wisblock ecosystem?
Yeah. Thank you for that introduction, Johan. So after our gateway discussions with Jose, we can now shift to the end devices. So right now, I'm going to discuss about the sensor hub. And as you know, RAK started to produce or to supply modules in the early times, as well, of course, the gateways. And then we moved to modular approach like what you said, Johan, that's the whiz block. So because of these capabilities and our knowledge that we gain on this development, we realize that we can do something out of the hardware that we have on the whiz block ecosystem. So whiz block, I mean the sensor hub is actually a showcase of our the possibilities of how we can use the WizBlock ecosystem. So this is let me introduce you the sensor hub. So this is the sensor hub. So it's I don't know if it looks small or big, but it's not really big. The gateway of Jose later is earlier is much bigger than here. If you look at my hand, is it can fit in my hand exactly. So it's not really big. So this is the main hub, the sensor hub. It's designed for outdoor deployments. As you see, there is no hole in here. It's really close. Of course, there are screws here, but there are ceiling here, o-ring ceiling. So and then at the bottom you'll see the ports. So there are two ports here at the bottom of the sensor hub. So this is where you will put the sensor probes. So I will show you the sensor probe right now. So this is the sensor probe. So we connect it using this connector. So this is a waterproof connector as well, so that when we deploy this outdoors, it will be fine. So the sensor probe inside this is a sensor. It's a WISBlock sensor module. So those sensor modules that you see, the RAK 1901, 1902, those sensors are actually inside this. So right now, the sensors that the sensor hub support are the temperature, humidity, accelerometer, and then the barometric pressure. But we will increase the supported sensors like the gas sensors, VOC, things like that. Those are very um, compatible to this. So in terms of mounting, you can have this clip mounted on the wall, and then you just snap it there. You can snap this, the sensor. You can snap it, and then it's steady on the wall. There's also an option to mount this in a pole. So in this edge, you can try to fit here the metal the metallic clamp that you can use to mount it on the pole, like what is shown on the photo. So the sensor probe looks the same. So there's just a sticker here on the probe that shows what type of sensor it is. So this is the sensor probe. Aside from this, we also have the sensor hub also allows you to connect what we call as the sensor probe IO. So the sensor probe IO is different from the sensor hub because the output, there's no sensor in it. What you connect here are external devices that has different protocols like RS485, SDI12 for 20 milliampere, of course UART, and then the some IOs, dry contact input and output. So you can use this to interface other sensors. So right now we have in our store weather station external sensor that we can plug in here. We have soil moisture, pH sensor, water level, Yeah, those are the sensors that we can plug here. So those are basically external sensors that we plug in here. So basically, these are the main parts of the sensor hub: the sensor probe I/O, and then the sensor probe. Yeah. So aside from this, we have some accessories we that you can have with the sensor hub. As you see, there are only two ports, so you can say, "Oh, if there are only two ports, can I just connect two sensors?" Of course, we think about that. So we have this splitter cable. So as you see, there is a one input, and then you connect this connector here, and then you'll now have two options. So you can now connect two sensor probes and sensor probe I/O by using only one port, using this splitter. And then if you need to connect more, you can use the same splitter to connect another splitter. So you're just making a tree, something like that. So by the way, the interconnectivity between the sensor hub and the probes are one wire protocol. So basically, there's a microcontroller inside the sensor probe that gets the data from the WISP block sensor module, and then it converts this information, this sensor data, to a one wire protocol that will be compatible to the sensor hub. Aside from that, we have a extension cable in case that you want to plug the your sensor away. Let's say you're deploying your sensor to uh, a different room, or maybe it's inside the metallic location. You want to put this outside so that it has access to the gateway. It will not be blocked by the metal room or something like that. So we have this extension cable that you can use. So you can just plug it again because the connectors are compatible to one another. And then I have another accessory here. So this one. So this is a external power cable. So basically, it allows you to power your sensor hub using the common barrel type DC jack connector, like this one. So when we connect this to the sensor hub, we can now power this using this standard connector. And then we can now plug it in our standard socket. The idea here is that not all sensors can be powered by battery. So there are sensors that consumes more power. So we have this option. Also, you can, maybe if you have a different power source, maybe power, let's say you have a solar setup, things like that. So you can get power from it using this cable, so power cable. The sensor hub, by the way, is powered by a lithium thionyl chloride battery. So it's a primary cell battery. The idea there is that you don't need, the idea is you, when you deploy it remotely, you won't charge it again, something like that. So the lithium thionyl chloride, it has 3.6 nominal voltage, really ideal for this kind of setup. No need to add some regulator that will get more drop voltage. Yeah, and then it has a good power density, energy density. So that's good. So I think that's all for the sensor hub. So I hope I was able to show you the different stuff that we have. Um, but of course, this is not for all. But we see demand from our customers looking for solutions or devices that they can use without uh, difficulty of programming. They need to develop it low level. They're asking for something that they just can buy, plug, and then connect it, and then it will run. So we have those inquiries. So the sensor hub is our offering to them. So this will fit on their requirements. Yeah.
Awesome. Awesome. Thanks, Carl, for sharing like this detailed product overview about the sensor hub. There is two things I would like to share. First, a question for you. When you're saying, when you're talking about the the charging battery options that we have, you mentioned solar, right? As an option, will the rank battery plus option that we have available for our gateway a good fit for this option as well?
I I don't think so. The battery plus is designed for the gateways. I am
Hmm.
not sure if the battery plus has a 12 volts output. We can use um, this
Exactly.
extension power cable, so we can get the 12 volts from it, and then we can plug it. Actually, not just the battery plus. If you have a system at home or in your current setup that you have accessible 12 volts, I'm not sure, it can be powered by solar or other source that can power the sensor hub.
Awesome, awesome. Thanks for clarifying that. And also, as you also share at the end, maybe this option will be like not for everyone, but it is nice to see like the second stage of the goal of Rack Wireless when we decide to create the Whisper ecosystem. There is a thing on the IoT ecosystem. Like right now, we can see like how things move more faster than in the past. But if we were talking about like 4 years from now, developing an IoT sensor from scratch, it was a process that takes time because first you need to validate something. You go to the field, you talk with your client, you analyze the needs of their clients, then you take a protoboard, you connect some sensors, some MCUs, some jumper wires, you create your Frankenstein as Jose shared in a bit. Then you go with initial production, just 10 PCBs, go to China, wait for them, test them, then you find out that there is a shortcut in one of the channels that you prepare. Like there are many things that can happen along the way, and this process takes a lot of time, like months, are months of testing and development. And what Rag Wallace did with the Whistle ecosystem was to create an ecosystem that is open source, that allows people to just get a model either on the MCU side, either on the connectivity, either on the sensors on actuators, and create a solution that fits the multiple needs that are out there. That is why it's an like a, as we say, like an ever growing ecosystem. We have like more than 100 sensors already available for this. And as I said in the beginning, one of the coolest things is that this is open source. So imagine there is a sensor that is not right there available. You can just go to our documentation, look at the files, download the schematics, download the 3D and Gerber files, and being able to, based on a template, create your own models out as well. And in some way, this is like the base technology of this ready to use or plug and play device that we already have here. So for those who are not familiar with programming, or not familiar, let's say, are not into, because they are more business oriented people, or probably they just want to save time on developing time, and they say this is already there, I can just take it out, receive it, handle a setup quickly over Bluetooth connection, over NFC or something like that, and then you are ready to go to apply multiple options over here. So it is nice to see like how the progress has been doing over the last years for the RAKwireless ecosystem on the sensor side, because we are well known as a gateway company, but we are investing a lot in bringing end solutions in order to help more individuals, entrepreneurs, businesses, and companies to deploy solutions in the short period of time as possible, as well as in the easy way as possible. As our motto is like IoT made easy, right? So it's pretty nice to see this. And in the closing side, you say like the software side. How is like the software side for these sensors? Like how, if I want to get started with it, which tools should I use in order to set it up quickly and deploy it in the different options that it have and it provides?
Yeah, that's a good question, Maria, because I discussed about the hardware side. So let me discuss shortly about the software side of the sensor hub. So the sensor hub is actually based on what, as we said, WISBlock, and it uses the RUI tree. So it's based on RUI 3 firmware, and because of that, it is compatible to Wiz Toolbox. So basically, the Wiz Toolbox allows you to configure the sensor hub. It allows you to set configurations to it. Let's say you put the sensor probe with temperature sensor in it. You can configure it without any kind of programming. It's a plug and play device in which the sensor hub will automatically detects the sensor that you plug in. So let's say you plug in a barometric pressure, and then you disconnect it, you plug in a different one, the sensor hub will automatically detect it. And then once the sensor hub detects it, it will show on the Wiz Toolbox, on the Wiz Toolbox application in your phone. So basically, there's no USB connections here. So basically, all is connected via wirelessly via Bluetooth. So you configure it via Bluetooth using the Wiz Toolbox app in the Android or iOS smartphone. And then once the sensor is detected, you can configure how long you want it. I mean, you can configure the interval of sending. Let's say you want it to send the data every 5 minutes, 10 minutes. You just click it on the Wiz Toolbox app, and then it will configure itself. As Also, aside from that, you can set some thresholds. Let's say your threshold is -5 degrees, or that's for the lower end. And then let's say you're detecting a high temperature. Let's say you are in a temperature sensitive area, or your application is temperature sensitive. Let's say your trigger is 32 degrees Celsius. So you can set that using the Wiz Toolbox application. So that's all done in the app on your smartphone. So there's no need to bring a computer on deployment. You just need the sensor hub, your phone, your smartphone with the Wiz Toolbox, and then that's it. You can easily configure it, plug everything, automatically detected, and then it will start connecting to your network server. Oh, of course. Aside from that, before I forget this sensor hub also supports NB-IoT and LTE-M network. So it's not just LoRaWAN. We have a variant that supports the cellular LP1 technologies. So yeah, this is really cool device. Yeah.
Which is one of the things that the Whisper ecosystem brings, the modularity. I was just saying, like you can like in a modular way, you can change different kind of connectivity, not just Wi-Fi. Sorry, not just LoRa and LoRaWAN, but we have other these options that are available out there thanks to the modularity that the main technology is offering us. So thank you so much, Car, for bringing this overview about the sensor hub. It's pretty nice to see this big progress that RAKwireless has been making on the plug and play side, because not all the people are there to develop something from scratch. So this can be a good fit for them to validate ideas and also to scale it them with this kind of technology. So thank you so much. And now it's the time to jump with Christopher over here. As we just were like talking, we bring some things about the Wizblog and about with Node Sensor Hub, as is like the main name of this family of product, which is with Node. But this ecosystem have more than 100 models, and we are still counting. And in the latest release, we have a great addition to this ecosystem, which is the audio-based solutions, and that is why we have Christopher over here, because thanks to this, we can say that he had the big change to jumping from content creator to solution architect over here, which is pretty nice. And in the past, you had the chance to share in this kind of event, and an integration of tiny machine learning using edge impulse. But right now it is something that already happened, and we have a like an end solution, either using some tools that you present us in the past as well as others. So first of all, congratulations for this and for this jump that you had. But let's jump into the audio solution first. So, can you share more about the first step into this kind of technology for the RAK products ecosystem, and how the progress was up to the day that we have today, and what our users can find in it.
Well, thanks for introducing me. I'm glad to be here showing these new capabilities on our WizBlock ecosystem. Actually, we know a lot of microcontroller brands out there, different architectures, different vendors, and we are used to those applications where we program something and the board just behave as we define, controlling displays, LEDs, actuators, simply gathering data from sensors and with some defined thresholds, taking actions or making decisions. But nowadays, machine learning has evolved in a wave that almost everyone is has access to it. And the best thing here is that those microcontrollers that we grow up knowing are capable of developing and running machine learning algorithms and applications that can work very well um, offshore for saying it for say something. That means that we don't have anymore to send data to a powerful computer to then process the information and make decisions on it. We can do that now on our microcontrollers. And WISP-Block is not the exception. We have three main cores that are capable, all of them, of machine learning applications. And yeah, the first steps were like not that hard to implement because RAK ecosystem works alongside very known and popular microcontrollers as Nordic ones, Expressive ones, and Raspberry cores. So yeah, actually those companies were implementing the technology, and as we are working with them, we took advantage of it. And yeah, that's it. I have something to show as an introduction of one of the main use cases and applications we develop with WizBlock, that
Okay,
is audio. And
awesome.
recently, we had a launch where we published our WizBlock audio solution ecosystem that works along with WizBlock. Oh, we know that WizBlock has a lot of sensors. And yeah, actually, why not to give the ability to hear to those boards, to those projects that we've been made for a while. And yeah, as you can see there, we have many options. And I want first to talk a bit about why audio is a great choice for machine learning. And I will show my screen if you um, let me see. Please let me know if you can see it.
Yep, we can see it over here.
Perfect. Um, Surveillance also is already known by using security cameras all outside a house or a certain place to always be checking what's happening out there. But when we are talking about energy, processing images is more resource consuming than audio. And if you all of you thinks a bit, when you are at bed at home at night, the the only or the sense that is always turned on even when the lights are off is the hearing capability. If we hear something breaking, we say, hey, what's happening? Let's see if this is here at home. Or if we listen a door open or closing, we can understand that maybe my brother gets into the house. Or what I mean is that audio, without a lot of data to process, lets us know what's happening in our environment. And as you can see in the right image, this is a pattern that is about omnidirectional microphones. What I want to highlight with this image is that using just one sensor, one microphone, we have a um, big range or a scope to hear in any direction. When we use a camera, we just can't see where the camera is pointing. So having a microphone in our living room can send me data if something is happening in the backyard or at the kitchen or in any place at home. So yeah, maybe we can save a lot of energy if we stop using cameras as our main surveillance system, and maybe turn on cameras just when I hear something. Maybe that's a good application to do. And how Wisblock came to help us. Well, in our Wisblock ecosystem, specifically Wisblock Audio, we have input devices that let us hear sounds, voices, and everything that is um, defined as sound with different kind of microphones. We have normal spectral microphones that work very well on our scope of hearing from 20 to 20 kilohertz. And also we have ultrasonic microphones. The first microphones, the non-ultrasonic, are very suitable for voice recognition, sound detections, animal detections, event detections, and ultrasonic microphones pues, are very useful on analyzing vibrations, the behavior of machinery, even bioacoustics, because there's a lot of animals that produce sounds that we can't hear. And I will talk a bit later about the uses of this technology. Also, we have cores. As I mentioned before, we have Nordic cores with LoRaWAN capabilities, expressive cores with Wi-Fi capabilities, also Raspberry cores. Besides of just hearing, we have the ability of produce sounds, playback music, playback notifications, playback alert sounds, and that's great. Also, if we have any application where our device need to do more than just pues, process audio and identify it, we can use the SPG modules to do that process for us and let us core to do any other application. And also, one of the ways we can implement this type of technology is using edge impulse. That I won't get deep here, but just as you can see in the first image, Edge Impulse is based on a tiny machine learning platform where you just need to acquire training data, recording sounds that you want to identify, glass breaking, a keyword, or any class of birds, for example. Create a big enough data set to understand what you're hearing, design a model, and deploy it back to your microcontroller. So this process is being done very easily with Edge Impulse capabilities. And if you are going more serious in the scope, you can use Cyberon. There is our solution, our pro solution for this kind of applications, where you just need to select the code you want to implement because RAK already trained the models, prepared them, and have a lot of keywords that are very useful on lining control, um, controlling music, and more than that. There's a lot of commands that we can use and work very well with our course too. About applications, I want to be brief here, and that's answering one of Maria's questions. Noise is a very important thing while we are working. For example, in a company, industry, if we can imagine companies with a lot of motors, moving parts, there is a healthy noise level that is important to maintain to have a healthy environment. With Whisplug audio, we can monitor the noise level of places. Also, we can use it for voice recognition, just as we talk with Alexa, with Google, with Siri, to ask them for something. Turn on lights, set timers, send messages, everything we can imagine with voice because it's coded by us. So yeah, if you have a very specific application, you can implement it with this. Also, we can implement this type of applications on machine monitoring. If I know how the motor sounds while working well, I can teach a model, look, this is normal operation. Every sound other than that is maybe a failure. So give me a notification. We can do that very easily with our ecosystem. Also, in nature fields, we can use this type of applications for bioacoustics. I've been researching a lot, and there's um, organisms that are preserving wildlife and detecting the presence of species that were considered extinct. And just by the sound that they've heard, oh my God, it's still alive. We thought it wasn't. And yeah, that's very good to preserve nature in in this field. And well, I will give a space for one of you to add any other question after a I show you some real examples of this technology working. So yeah, anything to add?
Well, Chris, thanks for sharing this and preparing like this short presentation about like the different use cases where this kind of new Whisplug audio solution can be applied for, and also like the options that we have like for the community. We can say it like that. That is by training your own models by using Edge Impulse, but also the Cyberon options, that is like the industrial and pro options that we are offering in an embedded way for these kind of solutions that are being offered for our existing customers as well. More than a questions, I know that you have been playing a lot with the Whisplug audio, of course, by doing your tests, breaking things, fixing things, and I know that you have prepared like a short demo that you would like to show us. So yeah, just take the time to make it happen.
Yeah, let me set up a bit a camera here to show you exactly what I want to. Well, I will go back to present so I can show you the hardware that we'll be using.
Of course.
Yeah, here at the left, this is the hardware that we'll be using for this use case that we'll be showing right now. And we can see a Nordic core with a PDM microphone and a relay module. These applications can be very well powered with batteries, which is a great thing. And I made this little enclosure just to have a safe implementation because we are working with main voltages here to just as you can see at the right image to control a desk lamp working with main voltages. So I will show you how this can easily works using a Cyberon model running on our core. Here, please let me know if you can see it well.
We can see
Here
it
we perfect. Here we have the enclosure enclosed. Here there's a little cutout just for the microphone to cap the sounds better. And by now we are powering the board by USB, but it can work uh, powered by a battery. And the model is set to let me control the lamp with just few um, commands. I can say, and this should shows me if it hears me. Hey RAKstar, lights on, lights on. Here we can see that first it shows in blue that it hears the trigger word, and then in green that it executes the command. Maybe my hand was like um, covering the microphone. That's why at the first command I said it wasn't answering very well, but that's great. I don't know if you can understand, but this is working without internet, without any application, just plug and play, and I can control it from far away without having to shout out very loud the command. And let's try to power off the lamp. Hey RAKstar, lights off, and that's it. And it's very useful. If we can, I always say that if we can control a lamp, an LED, we can control an industrial device and a motor, a something with more power or with a more important use case than just lighting something. But this is a great use case for this kind of technology, and I'm very excited that we can create this type of applications with Whisplug. And yeah, I also have a different another use case, but because of time, I won't be able to present it. I don't want to take much time, but I will explain you what's about. Just with this setup, using a Wi-Fi core and an ESP32 and a microphone, I train a model that learns how my doorbell rings and notify my cell phone with a pop-up notification when someone is at the door. Because why? Because sometimes I'm close at my bedroom watching Netflix and I can hear the doorbell and people get crazy saying me, "Oh my God, I'm at your door," and nobody hears me. And that's why the TV is very loud or anything. And as the door doesn't have a smart doorbell, I can make it smart with just a simple model, a simple hardware like this one. And now I can program this to send a notification to my phone, and nobody will be staring at my door for more than 5 minutes now. So yeah, that's great for me, and that's an example of an application that we can use using this type of technology.
completely. Thanks for bringing this demo, Chris. It is funny the like you are, even if you are implementing this technology at your house, you are leaving your guest waiting for 5 minutes. Just kidding. But it's nice to see like the different possibilities of integrations that we can do with this kind of technology for the different applications that you introduce us in a bit, like the bioacoustics ones, the machine failures, for example, voice recognition, and activate, disactivate things. Like there are many doors that are open by this kind of technology that we offer, and like you showcase like a an enclosure that you build for this, let's say, demo purpose, and in order to have everything centralized in one place and secure. But also, I would like to take just a few minutes more before ending this session today, and is that in addition to this whole ecosystem that it connects multiple Whistlog audio models in order to be able to drive this kind of solutions that Chris just shared with us, is that we have like a full processing kit and processing a speaker kit that it comes with a enclosure that has the different capabilities to either connect the different things that we need to connect to it, and also it is built for allowing the speakers to be out, and also the microphone to get all the information that we need to receive in order to do the work that it have to do. And this is based on the unifying enclosure, which is another new product that RAKwireless has into the products ecosystem, because we have the Whisplog ecosystem with more than 100 models out there. However, many people ask us like, okay, I have like all these models, but I need to build an enclosure for it. I don't want it to put it in just a generic box that fits as it has to fit. What can I do like just to having that as another alternative? And that is why we create the unifying enclosure. I think you have it over here if I'm not wrong. Well, no, just you. Let's go to the store and you can check it out quickly. Um, enclosure. So here you can see like a wide variety of enclosure that meets the different sizes of the different boards that are available on the Whisper ecosystem. And also it comes with different accessories that allows you to mount it in different places in a quick way. So it's pretty nice because now you have a range of products jumping from I have an idea. I want to build something. I want to get my hands dirty and build my own thing. Okay, you have the Whistlog. And you wanted to put it outside because you need to make the final test with your client. You put it into a unified enclosure and you're ready to go. No, I want to build my custom device, my custom IoT device. Don't worry. Now that you already developed based on the Whistlog ecosystem, you already know how the RAK wireless technology works. You know how to communicate with the MCU being used because you use it for your Whisplog. You already know how to use RUI3 because you build it based on that technology. Then you already know how to interact with Whistlebox. And by just using a WhisDuo, which is just the single MCU with the transceiver, the LoRa transceiver that allow you to handle the communication over LoRa, you're also able to build your own custom device without having to invest a lot of time in engineering because you already proved something based on the Whisper ecosystem. I don't have time and I don't want to to go through that development process. Don't worry, go with the sensor hub, which is a plug and play device, and then okay, I need to connect all this technology into an infrastructure. You have the WizGate family, and now you have the WizGate Connect that allows you to basically interconnect with multiple connectivities at its named highlight, the WizGate Connect. So I think it's a pretty it was a pretty excited year for the RAG wireless in general. It brings like a new products, innovative products that it's helping individuals, small entrepreneurs, like big companies, to move forward in the deployment of IoT solution for any industry. And we are pretty excited to see all the actual solutions being implemented with all of this technology that we have created just for you, and just because you ask for it, because that is something that RAG has. And is that since the beginning, we have all been hearing the feedback of our community to keep improving day after day, and being able to push a technology that is easy to use, that can be also affordable, and also that is high quality technology. So yeah, that is like something that I have to share before ending over here. I don't know, guys. Before concluding over here, first, like, thank you so much for taking the time today and participating with us on this session. But there is like any additional message as our final session of the year that you would like to share with our community of entrepreneurs, makers, and engineers like yourself?
Just in a few words, keep creating every day. Yeah.
Love it. Thank you. So, check car, something that you would like to add?
Yeah, as Christopher said, there are more. There, we are going to launch more things in the next year. It's been a good year for Rack, introducing so many products this year, and hopefully uh, we can showcase this more to a broader audience. So don't forget to share, to
Like,
inform your
like,
friends. Yeah, tell your co engineers, hey, this is cool stuff. Yeah.
awesome.
And well, I just wanted to say that, yeah, just like Christopher said, keep creative, do stuff, push to the limits what we have, and ask us for more, because we want to create a bigger and wider and more fun to play with ecosystem.
Love it, love it. Thank you so much, Guy. This was an excellent overview about the new things that Rag Wallet has to offer to its community. Please keep in mind that if you haven't watched the launch event video, I highly recommend you to check it out, because right there, like, we have like a pretty deep details about the different features, technical features, implementations, use cases. It was a huge work that all of our team do in order to make this launch video happen. So I highly recommend you to check it out. If someone have like any additional question, I saw some comments in top of the session, like people saying hi. To all of us. Also, asking for plug and play stuff. Yeah, we're making plug and play things right now. Also, highlighting that we are doing great stuff. Also, people excited about saying hi. RAKwireless, thanking to us. And no, I will say, like, thanks to you for being part of this. And yeah, if someone of you out there find this session interesting and helpful, we will appreciate if you leave some love on this video by liking and subscribing to the Rag Wallace YouTube channels in case you are already not subscribed. And also feel free to share this session with anyone who might find these new products helpful. So, as we see at the beginning, this is the last session of the year. So, we hope to see you all again in January. Many thanks for being part of this, and happy holidays to you all. I think that will be all, and thank you so much, everyone, for being part of this. Bye bye. See you later.
Goodbye. Thanks, Maria and Johan.
Ciao.